Hi guys, welcome to my channel. I'm John. Today we are going to create this stop motion clay looking text in Blender 3D using geometry nodes. Okay, so here we are in Blender 3D. So first thing we need to do is press A and delete everything. Then we need to add the text. Then press tab to go into edit mode and tap whatever you want. Then I think we can increase the character spacing to 1.4 maybe. We can also change the alignment to center. Then I also want to change the font. Choose the font you like. I'm going to choose Helvetica. Then we need to extrude it. We can add some beaver as well. Okay, then exit the edit mode, turn on the wireframe so that we can see the line. And now we can convert the text to mesh. But before we convert it, let's make a copy in case we need to make any changes later. Then we can hide this for now. Then right click and convert to mesh. And now we need to convert this triangular polygon to rectangular polygon. So go to the modifier properties tab, add a remesh modifier. Let's choose smooth, untick remove disconnect, increase the octree depth to 5. And the scale to 0.7. Just play around with this value to get the result you want. Then we need to split them into separate objects. So go into edit mode, press 3 to switch the selection mode to face select. Hover your mouse on the object we want to split. Press L to select link polygon. Then press P to separate selected polygon. Okay, now we need to do the same thing for the rest of the alphabet. Then press tab again to exit the edit mode. Select 4 of these objects, press R and followed by X and tap 90 to rotate it 90 degrees. Then press Ctrl A and apply the rotation. Then go to object and set origin to geometry. Then press M and add them into a new collection. Let's name it text. We can hide the collection for now. Then let's add a cube. Name the cube text animation. Split the screen and go to Geometry Node Editor. Add a new Geometry Node to the cube. Drag the text collection into the Geometry Node Editor. Take separate children, connect it to group output. Okay, next we need to animate the scale of the alphabet. We want it to scale up from nothing to their original size. And as usual, I want to add an effector to animate the text. So in the 3D viewport, add a plane axis. Name it effector. Drag it into the geometry node editor. Then to animate the scale of the text, we need a scale instant node. Then we need to get the position of the instant object. Add a position node. Connect it to scale. So when we connect the position node to the scale instance, Blender will get the position of anything that connected to this instant input. So in this case, Blender will get the position of these instance objects. Then we need to add a vector map node. We need to bring the position of the instant objects and the location of the effector together. Then we need the scale of the effector to affect the instant objects as well. Then we only want the effector to function in x-axis. So add a separate xyz. Try to drag the effector along x-axis. And we can see the effector is start working, but the instance object is keep scaling up. This is not what we want. We want it to scale up from nothing and stop scaling at the original size. So to fix it, let's add a float curve after the separate xyz. And now drag the effector again to see the result. Okay, looks good, but the effect is going to opposite direction. The animation should start from left to right instead of right to left. So to fix this, let's change this vector map to subtract. Drag the effector again to check the result. And now we have another problem. We actually want the alphabet to scale up from nothing to their original size. But now the alphabet is scaled down from original size to nothing. So to flip the animation, we need to add a math node before the float curve. Then we need to multiply -1. and now we fix it. Then let's select this node, press Ctrl J to frame it, then press F2 and name it Effector. Okay, next, instead of just scaling up the alphabet from nothing to their original size, I want to add overshoot effect to the end of the animation. So before we continue to add the overshoot effect, let's add the keyframe to the effector first. Make sure your thumb indicator stay at 0. Move the effector to around -3 maybe. Add a single keyframe. Drag the thumb indicator to 80. Move the effector to around 3.5 maybe. Add a single keyframe again. Okay, now go back to the geometry node editor. Go to the float curve node. And now we need to manipulate the curve to get the overshoot effect we want. So again, let me explain a little bit about this. The animation is actually start from this point. So as you can see, the value of the y-axis here is 0. That means the scale of our instant object is 0 at this point. Then at this point, the value is 1. That means the instant object has scaled up to their original size. Then at this point, the value here is 0.6. So that means our instant object scaled down slightly smaller. Then at this point, the value is 1 again. That means the instant object have scaled up to their original size again. Then at this point, it scaled down slightly smaller again. Then at the end, it stopped at 1, which is the original size. So now, let's play the animation to check the result. I think the transition is too fast and it looks unnatural. So to slow it down, let's make the effector bigger. Check the animation again. Okay, everything looks good for me. Okay, now as you can see, the animation doesn't look like stop motion at all because it's too smooth. So to make it look like a stop motion animation, in the float curve, we need to change the handle type from auto handle to vector handle. Maybe at some point to make the animation looks better. Okay, again, let me explain a little bit about this graph. So the animation is start from this point, and as you can see, the value of the y-axis here is 0. That means the scale of our instant object is 0 at this point. Then at this point, the value is 1. That means the instant object have scaled up to their original size. Then at this point, the scale still stay at 1. So that means our instant object will remain the scale at 1 for a while before it scale down again. Then again at this point, the scale is scaled down to 0.6 and remain the size until this point. And at this point, the scale is scaled up to 0.9 and remain the size until this point. So there's one thing we need to keep in mind. In order to get the stop motion effect, we want the value to jump from one value to another value in a very short amount of time. Let's say here the value is 1 and we want it to jump to around 0.6 in this short amount of time. So we need to keep the graph line as 90 degree as possible. Not really need to be 90 degree, but close to 90 degree is good. Next, I want to animate the rotation of the alphabet as well. So to do it, let's add a rotate instance after scale instance. Select this float curve and press Shift Ctrl D to duplicate it. Then we only want the alphabet to rotate in y-axis, so we need a combine XYZ. Connect it to rotation. So now reset the float curve. So for the rotation, we want it to start rotate from negative x-axis towards positive x-axis. Then go back to the negative x-axis and stop at the original rotation degree. So let's mute the scale instance for now. So if we refer to the float curve, currently the rotation is start from 0, which is the original rotation degree, but this is not what we want. We want it to start the rotation from negative x-axis, but now we are not able to move this point to negative. So to make the rotation start from negative x-axis, we need to change the minimum y-axis to -2 and the maximum y-axis to 2. Then let's reset the view, extend horizontal, and now we are able to change this point to start at -2. Then after -2, we want the animation to rotate to positive x-axis, so add a point and put 2 maybe. Then we want it to rotate towards negative x-axis again, add a point and put -1 maybe. Then we can slowly fade out the animation, put 0.1 for this point. Then we want it to end in the original rotation degree, which is 0. Then unmute the scale instance and check the animation. I think we can make it rotate in Z-axis at the same time. Okay, it looks a lot better now. Okay, now we can start to turn the graph from auto handle to vector handle. Next, we want to add the stop motion effect to the position of the alphabet. I want it to bigger after the alphabet scale up. So to do it, let's add a translate instance after the rotate instance. Then to make it bigger, let's add a random value and connect it to translate instance. Then to animate it, let's add a scene time and connect the frame output to the seed in random value. So in case you don't know what is scene time node, the scene time node actually output the current time in the scene animation in unit of second or frame. So when we say frame, it's pretty straightforward. In the timeline here, all these numbers are frame. So this is frame 0, frame 10, frame 20, and so on. So for example, now our time indicator is stay at frame 80. That means the scene time node will output a value of 80 to the seed value. And if we output the units in second, it will depend on how many frames per second we set for this project. So for example, now we have set our project to 24 frames per second. That means every 24 frames, the scene time node will output 1 to the seed. Okay, now let's play the animation to see the result. The vigor is super fast, so to slow it down, let's add a math node after the scene node. Let's divide 6 maybe. Okay, then when the vigor animation happens, the distance between each alphabet is too far. So to make it closer, we can decrease the maximum value to 0.06 maybe. You can try a different number to get the result you want. Play the animation to check the result again. Okay, everything looks good. Select all these nodes, press Ctrl J to frame it, then name it text animation. Then select 3 of these nodes, press Ctrl J to frame it. Name this vigor animation. Okay, next, we need to add displacement map to our text and we need to animate the mesh. So currently, all these texts are actually instant object. It is not real geometry and we are not able to apply a displacement map onto it. So in order to add displacement map to the text, we need to turn this instant object into real geometry by adding a realized instant. Then, to add the displacement map, instead of using a displace modifier, I want to use geometry nodes to do it so that we have more control over it. So let's add a set position before the group output. Then add a noise texture and connect it to offset. Now as you can see, the mesh has distorted into a weird shape. This is not what we want. We want the mesh to distort outwards, follow the direction of the normal. So to do it, we need to get the normal of the mesh. Then add a vector map node and multiply both of them. And now the displacement effect is too big. Let's duplicate this vector map node and scale it smaller. Then to animate the noise texture, let's duplicate all the nodes in the figure section. Press Alternate P to unframe it. Connect the random value to scale. Play the animation to check the result. It seems like nothing happened. This is because our distortion here is 0. So let's increase the distortion to 20 maybe. I think we can reduce the detail to 0. You can play around with this value to get the result you want. Let's try to change this to 4D maybe. Okay, it looks better. Play the animation again. I think the speed is too slow, so to make the texture move faster, we can decrease the divide number to 4 maybe. Let's increase the maximum value to 0.1 so that the effect will be more obvious. Okay, now let's frame all these nodes and name it Displacement Map. Then we can add a subdivision surface and set shape smooth to make it look better. Okay, next we can start to add background, camera and lighting. So in the 3D viewport, add a plane, make it bigger and move it lower. Go into edit mode, select two of these points, extrude it. Go to modifier properties and add a subdivision surface. Increase the subdivision level for viewport to 2. Press Ctrl R and add loop cut for every corner. Then exit edit mode. Then add a camera. Press numpad 0 to switch to camera view. Then go to the camera tab. Increase the focal length to 120. I think we can move the camera upward. Okay, now let's turn off the wireframe and we can start to add lighting. Switch this to 3D viewport. Press numpad 7 to see the top view. Add an area light. Go to render properties. Change the render engine to cycles. Device to GPU. Turn on the render preview. Then select the light and move it higher. Go to light properties tab. Increase the power to 100. Then I want a softer shadow, so let's increase the size to 4 maybe. Then I want to add a bit highlight to the left and right side. So let's duplicate the area light. Rotate it. For this light, let's reduce the size to 1. Then duplicate this light again and put it at the right side. Rotate it. Okay, next we can start to add material. So let's unhide the text collection and hide the text animation for now. Select 4 of the alphabet. Before we add the material, we need to apply all the remesh modifier here. So go to the 3D viewport, press Ctrl A and apply visual geometry to mesh. Then right click and set shape smooth. Okay, now select one of the alphabet. Go to the material properties tab, add a new material. Then go to the shader editor, press home button to see all the nodes. Change the base color to yellow color. Okay, then add an image texture. Then we need to add the fingerprint texture to the alphabet. So I have included the download link of the texture in the description below. Please download it and follow along the video. Connect the image texture to roughness. Set the color space to non-color. Select the image texture and press Ctrl T. But before you press Ctrl T, please make sure you activate the Node Wrangler add-on. And now, as you can see, the fingerprint texture is not appear on the alphabet, and that is because we haven't do UV unwrap yet, and we are not going to do it since Geometry Node is still not support it yet. So now we have to find a way to work around it to get the fingerprint texture. So let's delete the texture coordinate, and we need to replace it with an attribute. Connect it to vector. Then put a name for the attribute. Let's name it fingerprint. Okay, then let's ignore the texture for now. Select alphabet T, add a new material, hold shift and select alphabet P, press Ctrl L and select link material. Hide all the text in text collection. Unhide and select the text animation. Go back to the geometry node editor. Add a store name attribute before the realize instance. Change the data type to vector. Add a position node and connect it to value. Pin it. Select the alphabet P. Split the screen and go to shader editor. Go to attribute. Hover the fingerprint. Press Ctrl C to copy it. Paste it to the store name attribute in geometry node editor. And now as we can see, the texture is not obvious at all. So let's add a color ramp after the image texture. Then we can play with this color ramp to get the result we want. Then we need to add a bump node as well. Connect the bump node to normal. Connect the image texture to the height in the bump node. Let's make the texture slightly smaller. Then let's rotate it to make it look better. I think we need to invert the bump so that it will look like someone really pressed the clay. Okay, now let's unhide all the text in text collection. Select alphabet P, copy the material. Select alphabet S, add a new material. Paste material. Then change the base color to turquoise color. Select the O, add a new material. Hold Ctrl and select S. Press Ctrl L and link material. Okay, then hide the text collection. Select the backdrop, add a new material. Change the base color to blue color. Turn the roughness to 1. Then change the background color to blue color as well. Press numpad 0 to see the camera view. Move two of these lights slightly lower. Okay, now we done it. So if you like my video, please subscribe and see you in the next video. Bye.